Okay, let me do the full screen here. So we're a little bit late in getting started on this, but so our goal here now is to do not only the regression, okay? We have to calculate all of these things from the data points. We find the summary data, then we put them into here. The only two formulas, quote unquote, that we have, this is summary data. This isn't new. This is stuff we've done in the past. We have two formulas, the formula for R and the formula for the slope. I said V1, but maybe write the word slope because that's the coefficient that goes in front of the X. Okay, it's not the constant. Those are a big deal. Now, why is slope important? Well, slope is the simple idea that if I change one, I know exactly how much the other is going to change. So if your slope of something was 2 and you change the X input by a certain number of units, you're going to change the Y input by 2 times that number. And that's kind of how it works. So let's have a, sorry, I can't find a pen that actually works here. We'll do a simple example. And everybody has these hopefully written down, because we also did this last day. I'm going to give you some data points. We're going to do all calculations. And it doesn't have to be a ton of data points either. Okay, so let's start with 0, 3, 2, 9, 5, 14, 7, 17, and 10, 22. All right, so these are my data points. Just have 5 data points. So what I want to do, let's start. Let's find all of these things here. This doesn't take very long, but let's find them because we have to agree that we all get the same numbers. So we'll write them. And again, like Roz said, it doesn't matter what order you find them, just make sure you label them correctly. N is 5, so that's going to come in a moment. Let me get this thing over here to work. Ah, finally, it worked out. I think your threats, even though you weren't seriously going to beat up the computer, I think it saw the seriousness on your face and it said, I better shape up. Okay. So we're not going to do this yet, but I'm going to go ahead and erase this. And yes, Dusty, we will go back and do some.
I'm not sure which one. I have it, because I don't put it out yet, so I have it.
Oh, and then be careful because those are all shifted on you. Make sure you, when you parent them, those are supposed to line up. Yeah, we want to make sure they go together because those are your ordered pairs. The top one is the X, the bottom one is the Y. Yes, yeah. But you see what's happening as you go across? I think you don't have the 1 for 10. See, that's cut off.
Down there.
Oh, okay. I think Junior had that problem last day. He was doing something similar and he, what happened? He cut it off. And so he had a different number because of this. How about if you turn your screen sideways? Is it better? Well, just hold your phone sideways. Does it come out better? Comes up the same. Okay. Oh, there he is. Speak of the devil. All right, Robert, you got to stop talking about that. He's here. You know, I have I forgot to put them. I have the extra calculators and formulas. I was doing. Although you guys all have your own at this point anyway. For the final exam, I would rather everybody already have their own formulas. So if either today, next day, it doesn't matter, make sure you grab, in others, I mean, like the Z tables, the chi-square tables, the formulas, just grab some if you don't. Because the day of, I don't want to have to go back and make more copies. I mean, I keep doing that. So have your own formulas. I will always do the calculator thing, but again, day of the test is not the time you want to try a calculator for the first time. You always want to have that comfort, you know, the comfortable calculator.
I wasn't here last time, so did we decide that we're doing the exam on Tuesday?
No, the exam is Thursday. I said anybody wants to take it early. That's what I was saying before. I'm not giving it early. I just said if anybody wants to take it early, they can. And why would you do that? Well, because most of my students have physics and calculus and maybe chemistry and all this, and they're all, the finals are literally all the same day. So I always tell them, look, if you're taking your final a day early, it makes your life easier to take it a day early. The idea being, let's just say, if you're not ready Wednesday, are you going to be ready Thursday, the next day? Probably not. But if you got 4 finals on Thursday, moving one of them might make Thursday easier. That's why I always do that. I don't need anybody to take the final early. I'm just giving you the option if it makes your life easier. Don't take it early if you're not ready. No, that would be a bad idea. Because we're reviewing on Tuesday. But let's just say hypothetically you feel really good and you say, can I take my final later on Tuesday? You might want to take it after class. That's okay. That's all I'm saying. And again, I don't need you to, I just want you to know it's available, but you have to decide sooner. You can't like wake up that morning and say, yeah, I think I'll take my final early. That's something you probably want to have planned out. Yeah, I do that every semester in every class because I know how stressful finals are, you know, and you really want to be prepared mentally. All right, so what do we got so far, folks? 24.
Second one is 65.
65, and then this one?
Not yet.
Nobody's got that one yet? One, no, should be a little bit bigger. 178, good. And then the last one? By the way, everybody should be doing this because you want to confirm that you got the same thing. There's nothing complicated in the calculation, but if we hit them, you know, if we misenter, you forgot to hit the squared button, stuff like that, you know, things like that happen all the time. Now, the last one, just so you're not confused, it's 0 times 3 plus 2 times 9 plus. So you're multiplying rather than squaring.
How do you, what's the date again for times 2?
You added all the squares up. We've done that one a few times. So sum of the squares. Anybody got the last one? 427. Okay. There's no, I'm not doing anything. I'm just adding up a bunch of numbers. We're not doing anything yet. Now, I said there's 2 more things we need. We need the X bar and we need the Y bar because those are going to come into the later calculations. So what is X bar? X bar is 24 over 5 because there's 5 numbers.
So for the 427, you just multiplied.
Yeah. Okay. That plus that plus that plus that. Yeah.
5 set of coordinates.
So there's 5 ordered pairs, 5 ordered pairs, 5 points. So n is 5. Why is that important? Because that's what you're dividing by. And this would be 65 over 5. So my X bar is 4.8. Now, let's suppose my denominator was 7 or 13 or something icky. Then leave it as a fraction. Don't round it off and then re-enter a decimal later. No, if this, the rule is always the same. If this is not a terminating decimal, then you're going to use this throughout the process. There's no point in ever rounding off a fraction and then using the round off for the next calculation. You have a calculator, just enter the fraction. But That's a terminating decimal. So it's easier to enter than the fraction. Do you agree? I mean, would anybody enter 65 over 5? No, you'd enter 13 because it's
Easier.
this is easier. Yeah. It's cleaner too. So in the case, by the way, being the statistician, we've talked about this before. When we're going to have Roz shoot free throws, we're not going to have Roz shoot 104 or 97. We're going to pick exactly 100 because it's easier to work with. And it doesn't cause us to have to do anything extra. You would always choose ends that make your life easier if you could. Would you have a sample of 999? No, you'd have a sample of 1,000 because it's just easier to calculate with 1,000 than it is with 999. But do you always have control of that? Always? No, maybe not. Maybe you end up with just some funky number because that's all right. So now the next thing is the sum squared of the x's, the sum squared of the y's, the sum squared of the xy's. These are just straight up formulas, and all of them use this data to the left. Okay, and hopefully you have it written down because we did it last day and today. That's not a quotient. It's technically the numerator of variance. That's what I was talking about earlier. So you don't actually have to calculate the variance because variance calculation might not be a happy number, but the numerator is always going to be happy. 8 minus 5 times 4.8 squared. Actually, okay. Blue pens that are good. These are our 5 data points. Clearly, they kind of line up. Are they on the same line? No. Will they ever be on the same line? No, that's not possible in reality. But we expect we're going to get something happening. I like to do that just so when we're all done, you have a visual and say, oh, okay, that's what we just found. Now, does anybody have a number yet?
62.8.
62.8. Do we all agree? Everybody, yes? Okay. We have to agree.
214.
Exactly. We all agree? Okay, we're going to Salvador because I know he's a calculator maniac. He likes to actually have the answers before the calculator. 115? We got it? All right. Was that complicated? Now, the nice thing is for the rest of the problem, we're basically going to use these guys for the most part to answer our next questions. We had to do this in order to get these, but again, here's the beauty. If I had 1,000 data points and I had to do this by hand, this would take me a really long time. But this would take exactly the same amount of time as it just did this now, because I'm only using the results. I'm not doing 1,000 calculations. I'm just using those results to do these. You see the difference? It's huge. All right, let's start with the R. Okay, what does R equal? Okay, just so we don't forget. Which one was R? That was the XY on top, which is 115, and the square roots on the bottom, 62.8, and the square root of 214. Now, because you're dividing twice, you need to use parentheses, because you have a product in the bottom. Okay, so this is not tricky, but if you're not careful, you're going to basically move this X to the top. How do you know when you have a mistake? How do you know when you have a bad calculation? Easy. The value of R has to be a number between -1 and 1. It's not possible to be outside that range of values. So if you got a value that's really big, that means you got a boo-boo. Yeah, that's mathematical term. What'd you get? Is it between -1 and 1? No, that means you multiplied by square root of 214. Actually, you multiplied by 214. No, you multiply by square. So here's what you're gonna do. Keep it simple. You're gonna say 115 divided by square root 62.8 divided by square root 214. That's the only way you're gonna put that in the bottom. If you hit times, if you put times here, then you just move that up to the top. So you gotta go that way. If you want to avoid parentheses, just enter it like that. Tell me what you got when you get it done.
Oh, I got some, I'm not sure.
Okay, 0.99.
0.99. Is that a good number? Well, look at my picture. Okay, my perfectly computer generated picture. Do those points line up pretty tight?
Yeah.
So 0.99 is a reasonable calculation. Remember, what does 1 mean? 1 means they're on the line, not possible. -1 means they're on the line, but it's going downhill, by the way. +1 means uphill. We got 0.99 something? Does everybody get something? Okay. In fact, let's go maybe 4 decimals just to be safe.
0.9919. Oh, but we've got a round.
199, so technically 20. Now, in real life, you would rarely see something that good, but that would make you very, very happy because you're saying in simple English, whatever line I come up with is going to be an incredible predictor because the correlation is so close to 1. That means my points are lying so close to the line that if I give you an input, you give me the output on the line, that is a reasonable predictor. Now, does body mass index, you think, have an R that strong? No, because 2 people of the same height can widely vary. So in the body mass index example we were doing, my points are going to be, even if that was the same line, my points are going to be far more spread out. We definitely expect a positive correlation, but it's not going to be nearly this tight. Okay. Again, I know people that are the same height. How tall are you, Robert? 6'3". I have a brother-in-law, my wife's younger brother. He's 6'3". You are about 280, 290. My brother-in-law David's about 145. Now, my point that 2 people can be the same height and their weights vary drastically. Yeah, he's one of those kind of guys. He teaches where my wife teaches. He's one of those kind of guys that always wore 2 shirts in high school. You know, you know those guys. My younger brother was one of those guys. Always wore 2 shirts because he was so skinny. He didn't want the rib cage showing through. Now he's close to 200 pounds. You know, but the point being that even the BMI, 2 people of the same height can be wildly different weights, very different weights. And again, I'll use NFL players for, it's a perfect example. You have D lineman who might be 6 foot, 6'1" and 300 pounds. And then you have a wide receiver who's 6 foot, 6'1", 185, 190 pounds. Same height, different weights. So there is no such thing as a perfect predictor. There are just, and that's what we talked about, ranges. So now we want to calculate, we actually want to calculate the line of best fit. We need to calculate the B1 and the B0. So the B1, so the B1, now what was the formula I just gave you a moment ago for the B1?
Y hat equals.
Well, no, just the B1, not the whole thing yet.
SXY over SX.
Yes, SXY over SXX. So what's SXY? 115 over SSX, 62.8. Now, this is not a nice, simple number. It does reduce a little bit, but we're probably better off just, for now, just writing a decimal. 1 point,
830.
roughly 1.83. What that means is the slope of my line is about 1.83. It's a little less than 2. With that and knowing this, here's the cool thing. My line has to pass through this ordered pair with exactly this slope. That will tell us how to find the B0. Let me write it backwards. Whoops. In general, if I knew the following, if I know this, if y equals B0 plus B1x, and in our cases, we're going to actually use y bar and x bar because now I know that value, I know that value, I know that value. Agreed? Does everybody agree we know all 3 values? So then what's B0? It's going to be y bar minus B1x bar. I'm just going to throw that to the other side. So in our case here, y bar was 13 minus, I'm going to use the fraction because I have a calculator. I don't have to do any work, but I don't want to use the round off. I want to use the actual fraction. Remember, when your fraction isn't a terminating decimal, then always use the fraction in the next calculation. So 115 over 62.8, I'm doing all that on my calculator, times x bar, which was 4.8. And let's do that on our calculators.
And after this, I have a question, please.
Okay. Tell me what you get about. Now, again, because I'm just using the equation of a line, but I'm saying the line has to go through x bar, y bar. And the beautiful thing is I know that number, I know that number, I know that number. To get that number, just throw everything to the other side. What did you get roughly? $4.21. Does anyone else get that? Good. That's pretty good. Now we're going to state the line. So this is the part where we use the y hat. We're going to state our
You
line.
know what my question was.
Well, because you said y hat last time before.
Okay.
Our minds are becoming one,
Okay,
which
got
is a
it.
terrifying thing because you're going to start dressing in solid
Oh,
colors soon, and you know, and
the t-shirts.
yeah. It does make it easier though. Whichever on. People say, how do you decide? I go, whichever one's on top. I have a lot of t-shirts here, and the clean ones always go below. All right, so drum roll, please. What is the equation of our line of best fit? And now we write, this is why we write y hat,
Okay.
because it came from a sample. It's not the universe. I got 5 data points, not 5 billion data points. Equals B0. And by the way, you can go ahead and use the decimal because this is a fraction is not incorrect, but it'd be really impractical because it's so icky.
4.2.
Plus 1.83 times x. Now, 1.83, that's a little less than 2, agreed? So if I were to draw that line would look kind of like, you know, that. Okay, kind of that-ish. My line of best fit is above some of the points, it's below some of the points. It cannot be above all the points. It cannot be below all the points. Right? Because it would be, if I put it between the points, it's obviously going to be a little bit better. Now, here's the deal. How is this now useful to me? Whatever the situation is, you can make up your own input output. X might be the number of years with the company. Y might be the number of promotions you got. I don't know, you could think of, just make up a scenario. Now, if I said, all right, somebody came along and they gave me an input of, let's say, 8. Can you tell me a reasonable output? Yes, because if I come along and I gave you an input of 8, what would you do? You'd go to you go to the value on the line. That's what you do first, because that's your best predictor. So let's say the input of X equal 8, then what would my output be? Use your calculator. Wouldn't it be, where is it? 4.21 plus 1.83 times 8. I'm just taking 8, putting in here for X. Now, here's the idea. This is where the line of best fit comes in great. Now that I have the line of best fit, you give me any input, I'm going to give you the output from the line and say that's my best predictor of what the world would have produced. Now, it's the best predictor. Doesn't mean it's exactly correct. No, because in reality, what we always do, a cushion, a plus or minus. Again, if we had another couple weeks, I'd show you how to do that part, but that's a whole bunch more calculating.
So just to try to put it in an example for quiz 25, it says estimate the demand and the price is 25. So 25 would be the X. So you can essentially
You just put it in and then whatever Y it kicked out would be your exactly.
So, same question almost. So how did you find the X equals?
Oh, no, I
You
said,
made that up?
I just said, what if I want to input? Yeah.
Okay, just
So I have data. Now let's make a really simple example. Let's say this is years with the company, and let's say I don't know, stock options you purchased. So this person's in their first year, they purchased 3 stock options. This person's been there 10 years, they purchased 22, whatever. I have somebody who's worked for the company 8 years. What is the likely number they have? I don't know. What's the most likely number? Well, if I stick it in here, what does it tell me?
I see.
So everybody do that.
18.85.
You got 18. So you'd say about, because if I said stock options, we'd be talking whole numbers, right? So you'd say somebody who's worked there 8 years has probably got 19. Now, what if they only have 15? What if they have 21? In real life, wouldn't we say this plus or minus? We've done that before. Technically, we would want a confidence interval. Just like if I said the average height of the Mesa College student, I'd want a plus or minus confidence interval. You guys have all done that. So the beautiful thing about using regression to answer questions is the best answer I could possibly give is the answer on the line. Why? Because the correlation was so high that we would expect it to be very close. If the correlation is really high, then wouldn't you agree my plus or minus is probably very small cushion? Now, what if like BMI, my data points are all over the map? Then wouldn't our cushion be huge? So if I said, all right, I'm going to input somebody who's 6'3" into my BMI thing, what am I going to get as an output? Probably somewhere between you and my brother-in-law. You would be the plus, he would be the minus. I kid you not, that's exactly how this works. Why? Because BMI would have a very low correlation because 2 people of the same height can widely vary in weights, but we do agree the correlation is positive. It goes uphill, right? The taller you are, probably the more heavy you are. Now, think of you as an individual. I don't think there's anybody here that can say, yeah, when I was 6 inches shorter, I was much heavier. Probably not the case. You were probably much lighter when you were 6 inches shorter because you were probably much younger. Okay, now, I think I could be wrong, but have all of you stopped growing height-wise?
No.
You think you're still growing height?
Oh, for sure.
I stopped growing in
My
6th grade.
dad's great. My dad's-
Okay, so most of us have stopped growing height-wise.
I went down.
Well, yeah, gravity and all that, yeah. But generally speaking, most of you stop growing height-wise. You're not gonna get any taller. But will your weight continue to change throughout the rest of your life?
Yeah.
The answer is it can. It can change the rest of your life. I'm a freak in that way. My weight fluctuates during the course of the year by maybe 2 pounds, and that counts Thanksgiving and Christmas. And that's like every year. It doesn't matter it doesn't matter how much I eat, it doesn't matter how little. Yeah, it's a curse.
Last 2 years.
No, my weight actually has not changed even 1 pound in the last 2 years. Not even a pound. Because my wife bought me a bathroom scale, so now I decide to weigh myself every morning. I used to go like once a year, and my weight hasn't changed. Either that or the scale's broken, I'm not sure. But I weigh in at exactly 180 pounds every single day for the last 2 years. I think once I hit 181 and once it was 179. I can't explain it. It doesn't matter what I ate, when I ate, how much I ate, so I eat healthy. But the point being that it's unlikely, unless I completely change lifestyles, it's unlikely my weight's gonna go down as I get older. As we talked about, weight tends to go up as you get older because of the M word. Yeah, and that's something that's really hard to control. My father is very heavy. And I take him walking every day. He's not a young man. He's older. He's a bit older than me, yeah. And his weight, he's heavy. And he's probably never been this heavy. And he gets only a little bit of exercise and he doesn't eat a ton, but his metabolism is probably close to zero. That's what happens. That's why we actually study stuff like this, because then you can make healthier decisions. See, this is where statistics, again, applies to real life. And I'm using something that's controversial like BMI. Nobody likes it. Personally, I don't believe in it at all. I don't believe it's a one size. Well, it's a one size fits all that they try to put everybody into, which is just really not accurate.
You gotta calculate age in there, you have to.
Yeah, but lifestyle, what are you doing?
Yeah.
But at the same time, it's a starting point, and it actually is fairly useful when you're trying to measure things for a population.
For population.
Now, I just read something recently, we talk about in the United States. Do you know obesity is a problem in the United States for children? Right now, it's never been this bad in the history of the United States. Why are we having a problem with child obesity? Two things. They're not exercising and their diets are not particularly healthy, especially if you're eating, school food, that kind of thing.
Fitness cards for kids in elementary school because the problem stems in elementary school and they don't get enough quality.
Here for a minute. Go ahead, keep talking. Now, I had kids that just went through elementary school and I made lunches every day. And the other kids would just marvel because you saw what I eat. So I made them every day, big bins of fruit and vegetables and then whatever else. Whatever, it might be a protein bar, it might be something. And I would look, because I was parent helper often, I would look at what the other kids were eating. Those Lunchables and snack things, the prepared, ready-made, absolute garbage. I would never let my kids in a million years eat that kind of stuff. And that's what most of the kids are eating. And their snacks were usually candies and this was what parents were giving the kids because it was convenient. And I looked at, then I look at the school lunches, which they weren't terrible. But the school lunches, again, were not always filled with a lot of tater tots. that's a staple. That's a staple for student lunches.
You don't like any cheat day.
Yeah, but you can't have cheat meals every meal. I wouldn't call it a cheat day. Do I have my weaknesses? Oh, yes. Yeah. Oh, yeah. Friday, was it Friday night? Yeah, my son works at a pizza place down the street. The owner's my friend. And wings. Oh, but then, by the way, then I walked 15,000 steps after no joke, because I have a phone that just says how many steps I walked.
You're not human.
No, I'm not. But yeah, that's well known by people who know. That's for another day. Now, I want to go through now and do the problem from the quiz. If nothing else, understand that the simplest part of this. You have ordered pairs, meaning you have input, you have output. Number one, you believe there's a cause and effect, that the input affects the output, no matter what it is we're talking about. So it's not ice cream sales and shark attacks. Even though that appears highly coordinated, we know that ice cream sales do not cause shark attacks, unless they're really, mean-spirited sharks who, crave ice cream or something. I don't know. So we have a cause and effect we believe is in mind. So now, given a set of data points, ordered pairs, the first one has to be the input, the second one's the output. We come up with the calculation for regression. We come up with the line of best fit, and then we can use the line of best fit to predict. And that's what's actually done all the time in reality, but only if the data appears to be a fairly linear relation. Now, how many had pre-calculus maybe in high school? Do you remember doing maybe parabola of best fit or estimate? So what if, this is a totally separate thing, but what if the points don't line up on a line, but maybe they line up on a curve? Can I come up with a curve that fits the data? Yes. What if it kind of does this? Well, sometimes it might look like a logarithm. It might look like an exponential function. So in a pre-calculus class, you study other options. It's called nonlinear regression. This is linear meaning line. And so is that valid? Oh, absolutely. Absolutely, that's valid. Because what if your data is bending upwards? Then a line would not be a very good predictor, would it? Something else would. Do some things work that way? Yes. I mean, a lot of things will work where it's not linear. We're looking at linear data. So it's a little bit simpler from that standpoint. So let me go ahead and bring up now.
I'm gonna take a little bit.
That's fine. I'm just going to take a moment for me to get this up. So why don't you everybody take a little bit of a break? To me, this is some of the coolest stuff, but it's very specific, you know, cause and effect, input, output. Not everything works quite this nicely,
It's not.
but when it does,
It's just tedious.
it's tedious. And remember, in real life, you have computers. You're not doing handheld calculations, but you are making the same kind of conclusions. Okay, this is really taking. There we go. There we go.
So you wouldn't even let me eat lunch, Professor?
Say again?
You wouldn't even let me eat lunch?
I will fast.
I promise they ate some if their friends wanted to share with them at school.
People have wrong attitude. They think I hate dessert. I love dessert. I just don't have dessert.
That's.
You're not a real.
No, I get it though. 'Cause
You don't go to DJs and get a Kazuki?
It's,
I had a bite of the one. That was wonderful.
No, we're there, and I begin those.
Well, it's too far. The rule for me with dessert is it has to be really good. I don't eat candy. That's just it's got to be really good. And but no, I had a bite once. When my son finished his 8th grade promotion, we went there, and he's graduating in 2 weeks from high school now. He goes to school in Escondido, so I've only had a bite once. I've only been there one time, and it was 4 years ago.
you don't drink beer though, do you?
Oh, I'm an IPA man.
You should come back, because I work there now. That's great.
No, that's my go-to. The thing is, it's moderation.
I hear you.
A lot of people unfortunately, food has become their enemy, and they cut out food groups and things like that. I always think that's dangerous.
Can't do that.
It's moderation. Now, if things bother you, you know, for example, my oldest daughter is pretty sure she's lactose intolerant. So she's really never drank milk products, and she doesn't do cheese, which is really unfortunate because when my wife makes chicken enchiladas that to die for, she'll have to make separate ones without cheese.
I can concentrate. I'm so hungry now. Jeez.
I know. Yeah, but it's so early in the morning, you know.
Jeez.
No, I don't need pizza right now.
PB&J sounds good too.
Well, I got one of those in the fridge right now, so. Okay, hold on, give me one moment here.
Jelly fan. I just use peanut butter, but not jelly. No, strawberry jelly.
Well, no, if it's home and I put it in the toaster, I'm gonna just put peanut butter. But then I gotta have something to drink, because you can't have peanut butter without liquid. That's just dangerous. It's taking too long. Hold on a second.
And peanut butter is made out of like chickpeas and it's like a super healthy.
Well, it's not peanut butter anymore.
These ones?
Chickpeas are very good for you.
It's super healthy and it's really good.
Isn't that what, doesn't hummus come from chickpeas? Yeah. This is the last quiz. Okay, so everyone look at the question. Okay, so
This is a different phone. This is question 5.
yeah, same question.
After this, we're not gonna have it.
So input, output. So by the way, here's your ordered pairs, aren't they? Input, output, so on. And I'm saying, by the way, this is real life right here. As prices go up, what happens to demand in everything in life? Demand goes down. Prices go up, demand goes down. So the question is, do we expect there to be a strong relationship here? Probably. But our line of best fit is going to go downhill, isn't it? Because as prices go up, demand goes down. Everything in life works that way. Nobody goes, oh, gas is more expensive, let me go buy more. No, I'm going to conserve.
off their tanks, and I'm like, in this climate?
Well, yeah, but you know why? Because they're worried this is gonna be more expensive next time, so
Oh, yeah. It's $130 to fill up my truck.
that's ridiculous. Yeah, well, my wife commutes to Escondido every day, so, you know, I know it's bad. All right, so here's the situation here. Again, I give you 5 data points. I could give you 10, I can give you 20, but I don't want the calculations to take forever. So this is the exact same problem. Now, I said find the line of best fit, which means you now have to go, oh, I need to do some of X and some of Y. You've got to do all the summary that I told before, exactly everything in the same order. Okay. But I'm asking for the line of best fit, which means you've got to do everything, and then eventually you're gonna get to here. But you got to do all the summary. So the sum of the X's, the sum of the Y's,
I'm not gonna go any further.
I forgot my glasses again.
Correct.
Okay, that looks right, and that looks right, and that looks right, and that looks right. and- Beautiful.
I had to take a picture.
Oh,
I forgot my glasses again, I know.
oh,
Uh-oh.
I
You're in
know.
trouble.
Huh? So you can pull it up on canvas too.
on your driver's license, does it say you?
Uh-oh, I knew she was gonna get.
This is recent.
Okay. That is actually a thing.
My driver's license says I weigh 112. This is
And you're
recent.
saying that's not
And
accurate?
also, I don't carry.
Well, my driver's license says I'm 5'10".
Anytime I look at my license.
I'm not
I'm
actually
like,
fine.
damn, I'm
You
five.
Well, I was like 5'9" and 3/4 or 7/8 or something.
Hey, go
I've
for
been
what you
4'11"
say.
since
Exactly.
sixth
I
grade.
could have put 6'1".
There you
That's what I
go.
wanted to do. That was my target height, but I fell short.
I've been 4'11" since sixth
Target
grade.
height.
And each year I go to the doctor and they're like, oh, you're 4'11" point something, something. And it's like,
My youngest daughter is like 5'3" or something, and she's much shorter than all.
Your dad's not tall person?
My dad was he's much shorter. He's about 5'11". My mom was about 5'8".
Okay.
you see my dad's
So I'm the shortest of my brothers. But my wife is taller than me, and so both of my sons are taller than me. My wife's an Amazon.
really short.
You see Wonder Woman, that's.
Right.
I tell everyone, if you saw pictures of
Lindsay
her.
Wagner. Huh?
No, not the Gal Gadot Wonder Woman.
Oh.
No, that wasn't Lindsay Wagner, that was Bonnie Woman.
Oh.
No,
I forget.
oh God, she was incredible.
I forget her name. I could see her.
Linda,
I know.
you know what, beautiful brunette,
Yes.
Linda Carter.
There it is.
Oh my God,
That's
I was
the
in
name.
love with her growing up.
Wonder
Yeah,
Woman.
Gal Gadot actually looks like my wife, because she's just a little bit younger, but
Wait, what?
Wonder Woman, you see
Oh,
Wonder Woman? Yeah, that's my wife. That's my wife's story. That's where she came from. That's who they modeled the character after. Let's just put it that way. Yeah, my wife is taller than me. I'm very proud of that fact. You know,
It's okay.
well, and as a result, my boys are taller than me.
You see, I got my dad's skin. He's short.
So what is he wearing if you have to choose? Thank you.
Good job.
You're all week.
That was sad.
I know, it's just.
That was good. No, that was actually.
That was bad. That one was
So
bad.
your dad is short?
Yeah, and then my mom is average, like she's 5'5", like, you know, average size height. But her family is tall. So my brother, everybody else got the tall.
No, there's, you don't need a little way, but we just did the exact. Okay, so do this, guys, do this identically to the problem we just did. There's no difference.
That was.
The numbers are different. I'm gonna go ahead and pause the recording because all you guys are just calculating at the moment.